Hello, ladies and gentlemen. What a fine evening this is. So, this is Jeff speaking. I just wanted to go over a couple of points because, as I said above, there's, four bioinformatics students that I know of in our class of 95. And I can understand why some of this stuff would be a little bit confusing if you haven't programmed before. And I was talking to a few people about the assignment. A few points of confusion kept coming up again and again, so I thought I'd do a quick little itty-bitty thing to try and dispel some of that. So, above, I did my whole philosophy of programming thing, and you might not see how this immediately applies or is relevant or what have you, but what it comes down to is that I understand the purpose of the bioinformatics module in 308 to be to try and instill the mindset of a programmer in you. It's not to make you a crackerjack programmer. You certainly can't do that in 6 weeks or whatever it is, but you can try and make you think like a computer scientist. And this has two major benefits. I mean, one is that it gives you sort of a new way to approach a lot of problems outside computer programming. I know that learning to program has done a great deal to influence my way of thought in other areas. And number two, when we're all world-famous researchers out in the field curing cancer, ending poverty, and all that, it can be really helpful to have an understanding of just a little bit of how computers work under the hood. Because computers are used so widely, if we kind of understand how we can solve problems using computers and how programmers go about that, it should be quite beneficial. So, with all that said, the three main points I made above regarding philosophy of computer programming are these. So, one, computers are very fast but very stupid. Two, this means that computer programming is essentially the art of describing the solution to a problem in such stultifying detail that even something as stupid as a computer can understand what we're saying. And three, describing a problem in such extreme amounts of detail creates a lot of complexity for us because we have so many little details flying around, there's no way we can possibly keep it all in our heads. So instead, what we've done is we have created abstractions, which we can think of as black boxes. We know what goes into the box, we know what comes out of the box, but we absolutely do not care what is inside the box. And so then that means we can layer these boxes on top of one another. We get layers of abstraction, piled on more abstraction. If you look at how your operating system, how Windows or Mac OS is structured, you'll see that it's nothing but layers of abstraction, going all the way through different layers of software and hardware. So, with all that said, you should hopefully see how this begins to apply within Automator, and it should make the assignments that are coming in the following weeks maybe a little easier to figure out. I really don't know. I hope that's the case. So, with the philosophy established, why don't we take a look at Automator and see how all this applies. So we will fire up our wonderful little Automator. And I'm not going to go through all the stuff that was done in class because that would just be stupid. Just a couple of points that people found a little bit confusing that I think I could maybe do a little bit to help clear up. So when we fire up Automator, we get this thing asking us to choose our template. We'll do the application. Now keep in mind that according to the assignment specifications, we got to do a workflow and an application. But if you can do one, you can easily do the other. And the application shows something that's a little bit more confusing, so I just want to cover that. So it pops this up. We have our wonderful new empty application. Now, the biggest thing that I want to emphasize is how information flows through Automator. How we have the outputs of one action becoming the inputs of the next. And to show this, we're going to build this really quick, simple application. So we'll end up with an icon that you can drag files onto, and it will do things with it. So in a lot of respects, it's similar to the assignment. So we'll go down to utilities in our library, and we'll drag in choose from list. And this isn't ideal, but it does show the basic concepts we're trying to get across. So fire this up, and we want to show the list of files that the application receives as input. So we'll these are the files you dragged onto me. Wonderful. Now we have to save this before we can use it. And you could end up going and using the run button here, but that's not how we're going to be running our submitted application when we finish the assignment. So we're just going to use the same method that we'll be using, with our quote-unquote finished form, so you get a better idea of how it all works. So we'll file, save it, we'll call it happy example. And you should probably choose a more descriptive name, but this is just a stupid little hack anyway, so that's okay. Now we'll go to Finder, and there's Mr. Happy Example. Now if we run this haven't actually covered it how to run it, and this is definitely one of the points of confusion I ran across, which is why I'm covering it. The idea is that we can go into Finder, we can select multiple files. You can just hold down the Command key on your Mac keyboard to do that, or the Apple key. Then you click and drag these onto the icon of the example you created. That will run your application, and what do you know? There's a list of files we dragged on. It displays the full path of the file, but you can see it's untitled2.app, test.sqlite, and speaklol. So everything is just peachy. So we have our basic application working. Now let's take a quick look at what it's actually doing. The other point of confusion that I want to emphasize is that, I guess this is the original point of confusion, but whatever. This is a magic box. This application receives files and folders as input. That is a magic box. And you can think of it as a magic box because its output, the output of this action is the list of files that you dragged on to your application. And obviously, if you're going through and trying to implement the assignment so that you can drag files onto this icon, have them all move to a folder, obviously you need to know what files were dragged onto this icon. And the way you figure it out is by using the output of our magic box up here. And so you'll see that, again, using the convention that Dr. Jacob went over in the lecture, we have the output of a box represented by this triangle, and we have the input of a box represented by this circle. And you can see the two are connected, which means that the output of this box, aka the files that the user dragged on, becomes the input to this box. So whatever input this box or action receives, it will display in that nice little list format. So with all that said, you can see how we drag a file onto our happy little example. That becomes the output of the application receives files and folders as input box, which becomes the input to our display list. That pops it up. Everything's just peachy. So that's a really simple example, but it shows how files are dragged on, and it shows how information flows in Automator, how the output of one box becomes the input of another, and it always flows downward. We start with the topmost action, and we go down to the next, and so on. So this is cool and wonderful and great, but let's say we wanted to do something a little bit different. Let's say we wanted to ask the user for his name, and we wanted to display this name back to him. So we'll go and we will ask for text because we want to get the user's name. Now we'll say, what is your name? And we'll save this again, go back, and we'll keep running it the same way we did, even though we don't want to use the files that we drag on right now. So we'll just drag a file onto Happy Example to run it. This will pop up. And as expected, it asks for what is the name. Now, the confusing part is that it actually displays the name of the file that we dragged onto it. And, we don't want that. We want this box to be empty so the user can go in and type his name without having to erase all that. And the reason this happens is because the ask for text action will use whatever input it receives as the default answer. And if you look at the docs down here, it's not exactly clear that that's what happens, but if you play with it, you'll see clearly that's how it's implemented. So we don't actually want to use this magic input that we have at the top. We want to discard that. We want to ignore it. We don't want this to be the default answer. And so the way you do that is you just right-click on the title of the box up here, like ask for text, and you choose ignore input. Okay, so that's cool. We have to save again. We'll run it, and lo and behold, haha! No default value. Perfect. So the only thing left to do is we want to display this back to the user. So we'll go Utilities, Choose from List, just like we did before. And you'll note that the output of Ask for Text here becomes the input to Choose from List. And that's exactly what we want to happen, because the output of Ask for Text will be whatever the user entered, that is, the user's name, and that will become the input to Choose from List. So we'll just change this text. Your name is. I'll save this, run it, and hopefully it'll be happy. My name is Jeff. Okay, my name is Jeff. Ha ha ha! It's glorious. All right. So this is cool. Now let's say we wanted to go back and implement the same thing that we had before, as well as this, so we can show what files were dragged in. So we just add another Choose from List. We'll note again that the output of the magic box, the application receives files and folders, becomes the input to this. The files you chose were. And save this, we run it, and, well, before we run it, let's just talk very briefly what's going to happen. It's going to see what files you chose. It will display them in that wonderful list. Then it will ask the user for his name and display that as well. And the other thing to emphasize is that, again, these boxes here are not connected to one another. They are essentially separate. Like, this is one little flow of information where we ask for the username and we display it. And this is another flow where we receive the files that were passed in and we display it. And these two are essentially completely independent of one another. And you can actually think of them as two separate black boxes. Like, this whole thing here forms one black box where it receives the files and displays them in a list. And then this whole construct here, where it asks for the user's name and displays it as well, is a whole nother little black box. And these two operate entirely independent of one another. And so this is a very simple demonstration of abstraction in programming, of how we can essentially construct our own little black boxes that hide details that we don't care about. All we know is what goes into the box, what comes out. We don't care about anything else. We don't care about what's going on inside. So if we test this, I think it should be very nice. Aha, so it displays the file, and then it asks for the user's name, and displays that. So that's perfect, and wonderful, and glorious. Now, let's say we wanted to make an enhancement to this. Let's say we weren't happy with this. Let's say we wanted to ask for the user's name and then display the list of files. Now, why do we want to do it in that order? I don't know. It doesn't really matter. It's just a contrived example. But this introduces a complication, because to display the list of files, we need to use the output of the magic box up here. But the problem is, whatever uses the output of the magic box has to be the very first action. Because if we suddenly move this down here, so we get that to work, well, first of all, it's not exactly what it's going to be, but this illustrates what's going on more or less. This guy sitting down here, it no longer has access to the input files that were dragged onto our application up here, and that's a problem. Now, the way you get around that is by temporarily storing the list of files that were dragged onto us in a variable. Doing that means you can access the value of that variable later and do whatever you need with it. So to do that, we need to set value of variable. So we'll just drag this in here, and you'll note again that it becomes connected so that the input to set value of variable is the output of the magic box. We need to create a new variable, call it file list. And just like real programmers, we'll use no spaces in our name, and we'll use so-called camel case so that you have the humps of each new word being capitalized. Okay, so we're storing this in a variable. Now, what we have to do down here is actually use the value of the variable. And right now you'll see that the files you chose were, you'll see that's connected to the your name is, and that's completely nonsensical. I mean, we don't want to use the input to this list as the output of that. No, that's not what we want. So what we're going to do is we're going to use this variable value. So we need to get value of variable, drag that in, drop it here. And again, get value of variable, we don't want it to be connected to this, because we don't have any, it doesn't depend on the user's name or anything like that. So what we'll do is we'll tell it to ignore its input. So it becomes disconnected and its own little happy thing sitting off to the side. Specifically, we want to get the value of the file list variable that we stored back at the beginning of the program. And then essentially what happens is get value of variable outputs the value of that variable and becomes the input to this choose from list. So now if we save this and we run it, we should, with any luck, get exactly what we're going for. So I'll ask, what's the name? We'll say, name is Jeff. Ah, my name is Jeff. How did it know? All right, and then it displays the list of files that we dragged on at the beginning of the program execution. So this is actually pretty darn cool. So if we go back and we look what's happening, we'll see that information still flows top to bottom. Whatever happens up here is going to be executed before whatever's down here, before whatever's down here, and so on. But to actually be able to do what we want, to display the user's name here before we display the list of files here, we use variables. We store the list of files in this variable, then we ask for the user's name, and we display that here, and then finally we display the list of files that was stored in this variable. And I just want to emphasize again that going back to my whole philosophy BS, this gets into abstraction, into using black boxes. Because again, we can consider that these two actions up here are essentially their own black box. All we know is that it gets the files, stores them in this variable. Wonderful. Here, these two actions are their own little black box. We ask for the username, we display it. And finally, these two guys are their own little black box. We get the value of the variable, which was set by something up above, we don't know what, and we don't care, and then we display that in a list. And you'll note that between our three black boxes, we don't have any connections, not here and not here. So they're independent. They do not rely on each other's input and output. They exist independently, all by themselves, and this sort of begins to illustrate the idea of hiding all these ridiculously excessive details that we don't care about when we're programming, that only the computer needs to know about. And it starts to get you to think like a programmer, like a computer scientist. Okay, so that's about it for showing you cool stuff. I just want to go back and touch briefly on how all this ultimately applies to the assignment we've been asked to complete. Because believe it or not, all this contrived stuff relates directly to the assignment. So what is the assignment asking us to do? Well, it says, okay, we need to go and do a couple of things. We need to get whatever files were dragged onto our application. Then we need to create a new folder according to a specific naming convention. We need to add all those files to this folder, and then we need to create a zip file from that folder. And you begin to see some of the dependency issues that we are dealing with here. How this flow of information top to bottom interferes with what we're trying to do. Because obviously, to be able to move the files that the user selected into the new folder, the folder has to be created first. But to create the folder, we have to know all the stuff that we need to name the folder, like the tutorial group, the lecture day you're on, and the assignment number. So, incidentally, you don't have to worry about making the tutorial group and the lecture day dynamic. You don't have to worry about asking a user, what are you on Tuesday or Thursday, and what group are you in? No, because that stuff's going to always stay the same. That's never going to change, so you can just hard code that directly in your program. That's fine. The one thing that you do need to make dynamic, that you do need to allow the user to change, is the assignment number, because that will change from week to week, obviously. So you need to actually pop up a box that says, okay, what is your assignment number? Then you need to be able to store that in a variable, and so you can use it later on. But the problem is you need to do all that before you actually create your new folder. So essentially, the workflow that you might use would end up looking something a little like this. You'd ask the user, okay, well, first off, actually, you'd have to start by storing the files that were dragged on the application in a variable, so you can use them later on. Then, like we did here, you can ask the user what is your assignment number. You can store that in a variable. Then finally, using those two variables, you can first create a folder according to the right naming convention and embed the value of the assignment number variable into the name. So you get the folder named exactly as it's supposed to be. And then you can use the other variable, the one storing the list of files, to move those files into that folder. And then finally you can create the zip archive, which is really easy. One thing that I just want to mention that can probably make your life a bit easier is if you look at the create new folder. There it is. If you look at the new folder, and there is a saying in computer science, and well, programming circles in general. I'm not a computer scientist by any stretch, although I do fancy myself a programmer. The saying is RTFM, and it means read the fine manual. And of course, there is some dispute as to exactly what the F stands for, but I'm going to say that it stands for fine. And if we look at the fine manual, we can see very clearly that new folder, if passed an input, will actually copy those files into the folder. So that means if you can actually feed the value of your file list, or whatever you call a variable, if you can feed that value into the new folder action, it will go ahead and copy those files into your new folder automatically, and you don't have to worry about separately implementing a move or copy operation, which simplifies your life a bit. So if you can arrange things the right way, it's really not hard to implement. You can do it in a few minutes, hopefully, maybe, I'd like to think, and it will be wonderful and joyous and great and good. And just also remember that a lot of what you're seeing here in Automator isn't like what real programming is. I say real programming, finger quotes, which you can't see, of course, because real programming is, it's not exactly what you see in the movies, but it's definitely requiring you to go and type stuff. And it's a much, much more flexible way of doing things, because the graphical way that we're doing with Automator is certainly easier to pick up in the beginning. It's less intimidating, but it also imposes all kinds of ridiculous constraints on you, and we're starting to run into some of those, even with something as simple as what we've done here. So if you go ahead and, well, I just don't want people to get completely turned off by this. But, in subsequent weeks we'll get into stuff that's more codey, less graphical, and while it's a little more intimidating, it's also much more powerful, and it should also be less frustrating because you don't have all these stupid constraints that a graphical system imposes. So, just hang tough. Everyone here is a really smart, confident, wonderful individual, and, we're all going to be fine. We're all going to be just A-okay. Thank you.